Okay, so this question involves creating a system of linear equations and then solving it. Okay, so this is a question again that encompasses everything we've learned in this chapter so far, and it also asks us to use graphing technology to solve. So let's go through this. You've had a few minutes to take a look at this. Hopefully you've come up with at least one equation. You have to come up with two. So let's take a quick look here. So a large tree removes 1.4 kilograms of pollution from the air each year. A small tree removes 0.02 kilograms each year. An urban forest has 15,000 large and small trees. Together, these trees remove 7,200 kilograms of pollution. Okay, all right. So what I see first of all here is the forest has a total of 15,000 large and small trees. Guess what? We're going to try and find out how many of each size of tree are in the forest. So let's say L is large trees, okay? The number of large trees. That's the first thing we have to make sure we know. And S is the number of small trees. Does that make sense? So we're going to use those variables. If you used X and Y, that's great. I would use S and L because they refer to something. They mean something. So S plus L is going to equal what? Shout it out. 15,000. Good. Because that's the total number of trees. Equation number one. Real simple. Often is just a sum of the two. Often. That happens a lot. Okay. So the next part is a little bit trickier. But we have basically a kind of a rate for each tree. This is 1.4 kilograms for every large tree. And this is 0.02 kilograms for every small tree. And the total equals this many kilograms for all of them. So these three pieces of information make our second equation. And so 1.4 kilograms for every large tree plus what? 0.02 kilograms for every small tree equals a total of 7,200 kilograms. There's your second equation. Okay? So it's just a simple number of trees equation, and now what each tree does. Okay? So if it's money or if it's something like this, those pieces go together in an equation. All right. So there's our two equations. Graphing technology. All right. Well, okay. So what we need to do is we need to figure out which is going to be our X and which is going to be our Y. Okay? It doesn't really matter, but we kind of need to solve for the Y one, right? So which one's going to be X and Y? I don't know, it doesn't really matter. Let's make L, Y, and let's make S, X. Okay? So if you want to rewrite these to put them into your graphing calculator, I would suggest that. You certainly can. So this is going to be X plus Y is 15,000. That's the first one with X and Y. And then this is going to be 1.4Y plus 0.02x equals 7,200, right? So X and Y, because we're going to use the calculator knows X and Y. It doesn't know S and L. So it might be a little tricky to keep those straight. So I would rewrite the equations in terms of X and Y. And then we'll just have to remember at the end, when we find our solution, what X equals, the small tree, and what Y equals, the large trees, okay, the number of them. So turn your calculator on, or graphing technology, whatever you have. Let's get rid of everything else we have in there. Okay. And, are we ready to plug these into the calculator yet, or do we have to do something ahead of time? We have to solve for Y, don't we? Okay, so let's do that. We need to get Y all by itself. There's equation 1 in Y equals mx plus b, or just Y by itself. The second one's going to take a little bit more work, right? Not a whole lot. We need to get Y all by itself. So we need to do a little multiplication here first. So negative 0.2 divided by 1.4 is going to be negative 0.01428. Okay-ish. 2857. That's going to be X plus, what's 7,200 divided by 1.4? 5142.857. Okay, you guys agree with that? Anybody double check my numbers there? I got these all right? Okay. Okay, so here are our two equations. There's one and there's one, right? So now we can go ahead and plug this into the graphing calculator and find our intersection point. So let's go ahead and do that. Equation 1 over here, I'm going to go negative, remember this is the negative button, negative x plus 1500. Nope, is that 100 or 1,000? That should be 1,000. Sorry, I missed a zero there. 15,000. Go to the next line. That one's going to be negative 0.1428 or so. I think it was 857. That's fine though. Plus 5142.857. Oh, I forgot my x there. Make sure you put your x here. And you can insert things in the calculator. Second function, insert. You see that? Insert. Then you can put your x. If you don't insert it, it'll just copy over whatever you have there. So, all right. So we got some pretty big numbers here, don't we? 15,000. That's an intercept. So guess what? I need to make my y-intercept pretty large. I'm going to do that right away because I'm not going to see any of these lines right now if I graph it. So y-intercept has to be more than 15,000 for sure. So let's put that as 16,000. Okay. Look at the intercept over here in the other one. See 5142. You see it down here. So that's pretty big as well, obviously. The number of trees could get pretty large too. Look, we could have thousands and thousands of each of these trees. So really, the x maximum, we might have to increase that by quite a bit too, right? It could be 5 or 10,000 itself. So I'm going to go 10,000 because we could have 10,000 small trees. Hey, that's not unreasonable. Are we going to need to see the negative parts of the graph? No. We're not going to have a negative amount of trees at all. So we can just leave those as they are. That's pretty small compared to what we have. So let's graph it and see what happens. Okay. Oh, look at that. Oh, are we going to see it? Ooh. We might need to extend our x-axis a little bit more so we can see this intersection point. It might work there, but let's go back to the window. Down to the x max. I'm going to make this, maybe 14,000, let's say. So I'm going to change that x max to 14,000. Then I'm going to regraph it and see what happens. Okay? So anybody having issues getting to this point at all? There's your equations. Here's the window. That'll get you the same screen as me. All right, guys. So to find the intersection point, remember, second function, trace, intersect, and then basically it's going to show you, is this the first line you want me to consider? Yep. Is this the second line? Yep. Do you want me to guess an answer? Yep. There's only one intersection point on the screen, so it knows which one you want. Now, okay, so what happens if we have something like this, a decimal? Well, we're talking about whole numbers of trees, right? The calculator does a pretty good job of getting the exact point, but what you have to remember is that the calculator has really thousands and thousands of little points to choose from right around that intersection, right? So the fact that it would get the very exact point doesn't always happen. So what can we say that this is closest to, or this one is closest to? 10,000 and 5,000, okay? All right, so obviously it's saying, you know what, it's 10,000. That's pretty much 10,000. This is pretty much 5,000. So your final answer would be, you would write this down. It's a word problem, write a word answer. And so you would say 10,000 small trees and 5,000 large trees are needed. Whatever you want to write down there, okay? So there you go. Because that's the solution for the system of this linear equations. Okay? Any questions about that? All right.